understand what I'm missing.
Yes, yes. Um, so where to start? Okay.
Can I just warn you, I must leave promptly
Okay.
at 11:30.
Yeah. Yeah.
Otherwise, my wife will give me hell.
Yeah. Um, okay. So first of all, I do really appreciate everything you've done. Yeah. And I do really appreciate the support. Um, there are, I think there are some sort of key concepts that haven't really come across or haven't been emphasized enough. Um, so let's start with the relational holon first. Yeah. So with the four quadrants, there's also essentially a holon of the whole. Um, so in my overall scheme, I have the political power in the center. That's the power that spins the holon around. Yeah, it's the holon that spins the holon, if you like. Yeah. Um, and and that needs to be taken into account in the paper as well, I think. The other thing that came across, I saw that you were, say, I don't know, struggling or rejecting with the concept of every system being essentially structured with knowledge. Yeah. So everything in the universe is built from quantum information, and when those informational events are structured conceptually, they produce a knowledge structure which provides organizational constraints which manifest in terms of forces. Yeah. So the physics, the actual physics, is data signals which uh, which result in informational events which build the knowledge of things, and then those things arise through the utilization of forces which manipulate energy and mass. So that's what's actually happening from the physics perspective. And that's what I was trying to communicate with the example of the atom when it receives a quantum of information. Yeah, the actual knowledge structure of the atom changes. And I think that unless we acknowledge that everything in the universe is a representation of knowledge, and I'm not talking about our knowledge, I'm talking about the knowledge of the things themselves. I think we're missing a key utility, a key understanding, and that cycle is represented in the holon. And yeah, it isn't me it isn't just me that's saying this. There's James Sims in his book A Measure of Knowledge. There's another book I use which is Decoding Reality from this professor of physics. Essentially, the universe is quantum information, decoding reality. And another good one, where is it? Oh yeah, Estonia. Yeah, so this is Information on the Internal Structure of the Universe. Yeah, all of these three books are concurrent on that understanding. And I think it really is key.
Yeah, I'm puzzled because that's such a different
I know.
view of things that are from mine. And I'm finding it a bit difficult to get my head around it so that I can square it with.
Yeah.
See, I mean, to me, my philosophy is that we don't really know what's out there. It's the three worlds philosophy. So world one is only available to us through our system, through our worlds 2 and 3.
Yeah.
And quantum information is part of that. We have imagined it and used it to explain the phenomena that we observe in World One. But I don't see it as quite the same fundamental way that you're describing in all those three books. That you've shown me. Because to me, quantum mechanics is just a model, just another model. There's nothing. The only basic thing about it is that it's modeling at a quantum level, it's a subatomic level. You know, to say that the universe is made up of quantum information is a very foreign idea to me, because you know, if we're building an aeroplane or a bridge, we couldn't really care less about quantum information unless we're dealing with parts of the system that require it, i.e. the electronics, for example. So I think I have a different view of the world, and I can't square what you want to say with it, other than what I've said. On what basis do those authors claim that the world is made of quantum information?
Well, I guess you'd have to read the books.
I mean, I haven't read those books, so I'm not aware of them. So
let's. I mean, I give the relevant quotations in the paper, but I'm guessing. So this is just natural, you know. And again, this is an example of you know, an informational event. You know, the data is there, but because the data is not doesn't correspond with you know, your mental model, there's no informational event. And it doesn't mean anything to you, or it's rejected. And it's just natural.
Where in the paper do you refer to this? I've got it in front of me.
I quote Stoner in the paper. Could you share? I guess you've got it open at the moment. Could you share it?
Yeah. If I know how to do it.
I can try as well. Yeah, I'll find it in just a second.
I click share and it's disappeared off my screen. I don't know what I'm doing wrong. Oh, you screen sharing it.
Yeah.
Participants can now see your screen, but I can't.
Okay, it's all right. Give me a moment. I'll find the.
What do I click to make it come up? I've got you and me, but I haven't got the screen share.
It's the little green arrow at the bottom. Yeah. Okay. Right.
I haven't got a little green arrow.
It's all right. I can.
I've done the share.
Oh right. Okay.
It's gone. Given me a bar at the top that says you are screen sharing.
Yeah, I can see the start of the paper at the moment.
If I run a cursor over it, can you see me move?
Yeah, I can. I can see you moving your cursor.
Yeah. Okay. So what am I looking for?
It's all right, David. I'll do it. I've got it up at the moment.
You're much more adept at this than I am.
maybe. Sometimes I wonder. Don't worry. Need to make it a bit bigger. I think. Why isn't that moving? This is really annoying. Page width. Let's go there. Okay. Yeah. 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 Okay, so the way that we're using knowledge here may seem a bit odd at first, but it's in keeping with a measure of knowledge by James Sims. An individual's knowledge is directly proportional to its capacity to direct energy. Yeah. I mean, when he's talking about an individual, he's talking about everything. Yeah. Sims further expresses everything as knowledge and that all substances can be categorized by the amount of knowledge that they possess, and that they can be further classified by type of knowledge.
Hold on, I'm trying to just find it on my.
Yeah, it's
because I put comments and it's got a
page
different
5.
page.
Yeah, it's on my page 5.
Yeah.
Yeah.
I've got it.
It's in
Right.
the foundations for the framework part.
An individual's knowledge is directly proportional to its capacity to direct energy. I could sort of see what that means.
Yeah.
Everything has knowledge, but what's everything?
Everything. Everything.
A piece of steel doesn't have
Piece of
knowledge.
steel has knowledge. Everything in the universe has knowledge because it's structured information.
Okay, so you're redefining knowledge from what the normal understanding is.
Yeah. I don't know of a better word to describe it. Yeah. And it relates directly, to Shannon's equation with, the relationship between information and knowledge. Knowledge is structured information.
So let's take this slowly. Statement number one is knowledge is structured information.
Yeah.
What is information?
So information is it's defined in terms of the physics. I've got it somewhere. I think it was defined further up. Yeah. Okay. The okay. Okay. According to relational theory, this conveyance can start as a signal from the originating thing. It is a source of data. When this data enters a context, it becomes information. Information is the language nascent.
Right. We need to unpack this a bit.
Yeah. Here is the formal definition of information from a physics perspective. The informational context of an event is proportional to the log of its inverse probability of occurrence. The information is actually an event. Yeah. Data is the starting point, but unless that data interacts with something that brings about meaning, there's no informational event.
But an event is a point in a process.
That's right. Yes. Yeah. So you could
now,
say
why the log? I know that's defined in entropy, but that's just an assumption. I mean, I've always had trouble with the informational
this
definition of entropy because
well, we could look it up. Yeah. So, like I say, I've used the definition in this book. Yeah. So Vedral is a professor of quantum information science at Imperial College. He's actually at Oxford now. He's Oxford Professor of Quantum Information Science.
I didn't mean to say he's right.
Yes,
well, he has got a pedigree. I like that.
Yeah. So Vedral takes us from Claude Shannon's definition of information, devised to improve the quality of telephone lines, to the growing recognition of its profound importance, its deep connection with entropy and thermodynamics, and its reformulation for the quantum world. We see how modern science shares the wonder and spiritual quest of sages east and west, and draws us towards a possible explanation for the universe, an explanation of exquisite simplicity, strangeness, and beauty. The universe.
Sorry, Gary, I can't fully hear you.
Okay. Yeah.
So the second statement is a signal.
Yeah.
Now, a signal is only something that we recognize as a change in the physical world.
Yeah, it's a disturbance in you know.
So a signal, that the second statement is not about information. The second statement is a signal is defined as a change in the physical world, which we detect through our senses.
Yes.
Sorry, I'm just writing it down longhand.
So so if we detect something, then it's meaningful to our physical form.
That detection is a change in world one.
Yes.
Forgive me for.
No, it's okay. Yeah.
We're a bit slow here.
You know that helps.
I'm just trying to just square it with my own understanding.
Yeah.
There's this change in the physical world, which we detect by a change
in our world too.
In our sensory perceptions.
Mm. Yeah. So our world, if I'm right, our world two is our interpretation of world one. Yeah.
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 But then we share it in world three.
Yes.
Okay, that's helpful because that's.
Yeah.
I can see how that's very basic.
Yeah.
Right. We've defined a signal.
And I guess we're also part of world one, aren't we?
Of course.
Yeah. Yeah. So the fact that it's had an impact on us means that it may well also have an impact on a world one.
Yeah.
Through that relationship.
So the signal is the source of data.
Yeah.
So is that a series of signals or a changing signal? Is that what's meant by that?
I guess. I mean, the signal again is an event, isn't it?
So it's a single thing, a single state of the world.
Yeah, yeah, yeah. So a single signal will have an associated single piece of data. Yeah.
But normally we think of a signal as a changing pattern, like a sine curve or something.
Okay.
Yeah. So
Yeah,
when the signal changes through time,
yeah. The data
we,
changes.
does that make it data?
Yeah, so the change in the signal is also data. Yeah. So
Sorry?
I mean, if you follow the S curve, yeah, every movement through the S curve is a change in data.
What's the S curve?
You were talking about sinusoidal wave, for instance.
I see, yeah, yeah. So signals changing through time. This is statement number 3.
Yeah,
Signals change in time. And that is data.
yes, yeah. So yeah,
But we perceive that data in a context.
yes,
That's
yeah,
our world 2
yes,
context.
yeah, yeah. So when the data enters a context, it becomes information. You know, an informational event has occurred, which has an impact on world 2, for instance, our world 2.
Yeah.
But it also has an impact on our physical world 1. Yeah,
Yeah, and it's shared in world 3.
yeah,
So information is the impact on the receiver by the data. The context.
yeah,
Okay. In
yeah,
fact, we could say that if information does not have an impact, the relation, then it's just data and zero information. What do we mean by an impact here?
a change. Yeah,
I mean a consequent change.
yeah, yeah. So if you receive data which has yeah, if you receive data, if you receive a signal which has no impact, well, you don't even receive the signal. You know, it just goes over you. Um,
You mean you're unaware of it?
you're
You're
unaware
ignorant.
of it, or it. I guess you could say that the fact that you make a decision to ignore it is it still had an impact. But it's like you receive you something occurs which it just has no impact on. We can use the analogy of world 2. It's had no impact on your world 2. Yeah, something has happened. It's just not affected your knowledge at all.
What happens when a tree in a jungle falls over and nobody experiences that event? Is that zero information?
Well, there's no observer. You know, the person isn't there.
There's no observer.
Well, the observer in that particular case is the trees in the forest. Yeah. So that
Well,
they notice that the tree's fallen.
the famous philosophical argument for
Yeah.
God
Yeah.
is that he is the ultimate
Observer.
observer.
Yeah. Well, you could say that of the
So
universe as well. You know, the universe
he exists
observer.
because he perceives the tree falling over in the jungle, but no human being or animal does.
Yeah. But the universe does.
This argument is slightly different
Yeah.
because it's saying the tree has information
Well,
by
there's been an
virtue
event.
of it,
There's been an event. Yeah. And for
by virtue of its structure, and the ground and the insects and all the things that surround the context of the tree,
yeah,
they all have information too. So when the tree falls over,
they all have knowledge.
it might kill an animal, let's say, just for the sake of argument.
Yeah.
And the animal other animals around know that animal is now dead. The tree's fallen over, but we don't. We humans. Now this is a bit difficult.
Let me close the door because I'm picking up a bit of noise from outside. If that helps a bit. But we've got builders next door, so it's quite noisy.
Anyway, I mean, what we're trying to get at here is, what is a relation?
So when the tree falls down, it generates signals,
Yes,
and for the things, there are certain things in its surroundings that for which those signals have meaning. Yeah.
yes,
So there are informational events that take place. Yeah. So the knowledge of the trees and the ants and all of the things, and even the ground changes.
yeah,
Yeah. So when the tree falls, there's a signal in terms of a physical wave, a sound wave that goes through the ground.
yeah,
And that might have an impact on, say there's a rock. Yeah. Say there's a rock. Yeah.
yeah,
The sound wave hits the rock. Yeah. And there's an informational event on the rock such that its organizational structure is disturbed. Yeah. And it falls apart.
yeah.
So the very nature of the rock has changed. Its knowledge has fragmented as a result of the informational event.
Okay. But we are completely unaware of that. So that's quite nice, because it's something which doesn't depend on human interaction.
Yeah.
And of course that's obvious, isn't it? That things happen that we're not aware of.
Yeah.
But let's say that tree isn't a tree, but it's an earth tremor
Mm-hmm.
that is very small, has very little local effect, compared with, say, a tremor, which is quite large. It's the
Yeah.
same kind of event, but
Yeah.
it would be perceived by humans, especially nowadays, because we've got ways of measuring ground waves, and so we know when earthquakes happen,
Yeah. Yeah.
where they happen and how big they are,
Yeah.
even though we're not there.
Yeah. Yeah.
So I think, Gary, we've got to try and
Tease that out.
and tease this out and describe it in words, which are what you've written there is right, in the sense that you're reflecting what you understand there. But I think to the reader, it's so densely expressed that unless you've got a background in this kind of way of thinking, it just looks like words, I mean,
there's no information.
I know.
Yeah.
I know the problem, because in philosophy, when philosophers write, they often use similar language, and there's a lot in it. But unless you are another philosopher who's used to the context of what they're talking about, it's just words, and sometimes it's completely. I mean, if you read Wittgenstein, for example, it's completely unpackable. I mean, it's very, very difficult to understand what he's getting at.
Yeah. Yeah.
Clearly, people like Bertrand Russell, when he first read Wittgenstein, could see that. And so he brought him on and suggested he was one of the important philosophers of the century.
Yeah.
you and I, if you pick up Wittgenstein's books, they are incredibly dense and difficult to understand.
Mm.
And I think we've fallen into that trap a bit here.
Yes.
Anyway, we need to now understand what a relation is, though. Is a relation one where because there is a connectivity between signals, that one influences the other, and that nature of that influence is a relation.
Yeah, yeah. I think you could probably. So I'm just going there. You could probably say that a relationship is as a result of of shared knowledge of the other.
Sorry, is what of knowledge?
A relation, a relationship requires shared knowledge.
Shares.
It requires knowledge of the other.
Okay. Yeah, that makes sense. And the mutual the word interaction needs to come in here, doesn't it?
Yes.
Through that sharing.
Yes.
There is a mutual interaction which causes mutual change. So both parties in that interaction change.
Yes. And that's the whole, that's one of the key premises of the quantum effects. Yeah, everything is in relationship.
That takes us back a little bit to a signal.
Yeah.
This is a theory of, this matches up with my view that everything's a theory of change. We could call this a theory of change. Has anybody else in those books you've read, do they use that term?
Look.
If you look in the index of one of them, does it have anything under change? Imagine that depends on the quality of the index.
Yeah.
But it would be there if they gave it any importance.
Yeah. So change isn't mentioned by Stoner, but it's implicit in almost everything he talks about. There's anything about transformation. There's transformation. He talks about transformation and transducers.
Okay. So that's a good point. What's the difference between transformation and change? If you look it up in the dictionary, it will say transformation.
The same thing, isn't it? So with the change, there has to be a context of that change. So transformation is just more explicit about what is being changed, I guess.
But the transformation is the how of the process.
Oh, that's interesting.
Hmm? Well, you know, in my
Yeah,
earlier view, if you like, before this discussion,
yeah,
um, the potential that drives the change is through a transformation. Sorry, a potential that creates flow, which is change in time,
yeah,
flow. That transformation from potential to flow is the
yeah,
is the how. So,
yeah,
in shorthand, I say potential equals how, brackets, who, what, why, where, and when, close brackets. You've certainly given me something to think about
yeah.
here,
So,
Gary.
yeah, so there's another really good book from Carlo Rovelli. It's
Sorry?
Carlo Rovelli. Another. I'll stop sharing and share it.
Arlo Rovelli.
Rovelli. Yeah. Again, it's not very expensive. So he's a he's a quantum physicist. Um, and so here, Caravelli, one of the most influential thinkers, illuminates competing interpretations and offers his own original theory, the relational interpretation of quantum mechanics, where the world is fundamentally made of relations and chain and events rather than permanent substances, where we, as
Yeah.
every other thing around us, exist in our interactions with one another in a never-ending game of mirrors.
Never-ending game of mirrors.
Yeah, yeah, yeah.
That-
He's a
That's
theoretical physicist who has
that's a
made
bit of
significant
literary
contributions to the physics of space and time.
interpretation. Right. What we need to do, Gary, I think, is to write down a number of statements
Yes,
that get us from that understanding
yeah,
connect
that was
with.
what I tried to do. Yeah, but I'm sure I've made too many jumps. Yeah, I've made
Well,
too many.
I prefer to make one-off statements
Yeah,
in a list
yes,
that takes you from one thing to another. So
yes,
we start with defining something rather basic,
yeah,
like a signal
yeah,
or a change in perception in world one that we detect in world two
yeah,
and share in world three.
yeah. I agree.
Start with that
Yeah,
and move on to the quantum,
yes,
through to the idea that knowledge is structured information.
yeah,
Now, the one thing I'm not yet resolved is the log term,
mm,
because as I understand entropy,
yeah. It
the
is
only
connected.
reason for understanding information as the log of the bits is that it captures
Yeah, yeah.
something about what we understand and fits with some. There is some. I need to look at it again, but there's some fit with
There
thermodynamics.
is. Yeah. So I've, I've, I'll, I'll, s- I'll send you the link to a Wikipedia article relating entropy and information. Um, I can't remember I also saw something else, which was basically explaining that entropy is as a result of um, is it lost information? There's a direct relationship between entropy and loss of information,
Well,
something
that's
like
how
that.
it's in. That's how it's interpreted.
Yeah.
Entropy is supposed to be a measure of disorder.
Yes.
And quite how you justify the log term in that argument. I mean, entropy in thermodynamics is the summation, the integral of dq over t, isn't it?
Yeah. Yeah.
Now, Q is heat flow, T is temperature.
Yeah. Yeah.
So you've got two terms there, one of which you could interpret as a potential, that's T, because you've got a difference in temperature between 2 points. That creates potential for the flow of heat between the 2 points.
Yeah.
So how do we square that with the log definition? Does that page you're showing mention
It does, yeah. So
physical?
I think P, is it P that's the probability?
Well, P log P. But where is the connection with dq over t?
Maybe it's down here further, I'm not sure.
It's not on that page, is it?
No.
People have thought about this, I know.
Yeah, yeah, yeah.
But you know, my understanding from years ago when I worried about this is that the log assumption is just one that works. It didn't really connect with the physics of dq over t or thermodynamics of it. But I think people have made that connection.
Yeah.
We need to understand that.
Mm.
Oh, there you are. Look, entropy in information is directly analogous to the entropy where your arrow is in statistical thermodynamics.
Yeah.
That's the thing.
Yeah.
It's the statistical. Yeah. So a gas is a set of molecules moving randomly round and round.
Yeah.
It's hitting each other and hitting the surface, and therefore of the boundary of the container, and therefore creating a pressure. And that sum of all this, of the collision, as it were, is the explanation of pressure.
Yeah.
And I'm not quite sure how you get to volume. And maybe the volume is the constraining part of that.
Yeah.
We just need to explore that a bit, because I'm not happy with just saying log without really knowing
why and explaining why. Yeah. Yeah.
Because what we could be, you have opened my eyes actually this morning, is what we are saying is something quite important and basic.
Yeah.
And not well understood.
Yeah. Yeah. See, for me, this really corresponds with, I don't know, justifies, explains the relational model in terms of the actual physics. Yeah. So everything in the universe is a source and sink of signals. When those signals interact with something which is capable of receiving those signals, there is an informational event. And that informational event has an impact on the knowledge structure of the thing, either its physical structure or its mental structure, if it has a mental structure. Yeah. And that then results in forces which manipulate energy and mass, and essentially the creation or the transformation of things into new things, which have the potential for new signals. So that's what's happening in the relational holon in terms of the physics.
But where's the how do you describe the potential? I mean, potential is
The potential
in mechanics.
it's the potential for
potential is changing velocity, isn't it?
Yeah.
So these, for the sake of expression, these signals are coming from something that's moving. And that movement is accelerating. And that's in traditional mechanics. That's what creates a potential for the force. So
I've got an idea. So again, it comes into the concept of holarchy. So everything is a system, but also a part of something greater. Now, when you've got two systems that are parts in something greater, the greater provides essentially the organizational constraints on those parts. The modes of operation. And the potential modes of relationships. Whether that's I don't know, an electronic or a physical, or actual, I don't know. What I'm trying to say is that it's the overarching structure that provides the potential for the parts to interrelate. And that those potential interactions are enabled by the overarching organization, and that overarching organization at the highest level is the basic forces and nature of the universe. But if you're establishing a team, for instance, what you do is you establish the basis for potential relationships of the team members. So there is essentially a probability of an event in terms of an information or a data exchange, an information exchange, informational events across the people, because of the nature of the organization, the organizing constraints.
So is the most basic statement we can make that everything in the universe is moving?
I think we can say that, yes, because of time.
I mean,
everything is moving.
It's got to be moving. In other words, to have, it's put it this way: it's not at rest.
Time exists.
Whatever at rest means, because obviously it depends on your
oh dear
framework of relativity. We get into relativity there.
It is, yes. It does bring it all together.
I wonder what relativity theory says about movement.
Relativity and movement entropy. That's it. That looks interesting.
Does relatively objectively define entropy? What does that come up with?
Special relativity is free of entropy. However, in general, relativity gravity can be considered entropy of space-time.
That's only Quora. That's just somebody's opinion.
Right, yeah.
I wouldn't go with that.
No, relativistic nature of entropy changes. Does that sound interesting?
Yeah, that's a book.
As an arrow of time.
Yeah. Well, it'd be worth looking at and thinking about.
Yeah. Here's another one. A relativistic paradox and its resolution of, or who drives the entropy current between two bodies in relative motion. Yeah. But again, we've got to be careful that we don't get accused of cherry picking, haven't we?
Yeah. Yeah, I don't want to claim I know anything about relativity other than it assumes that nothing travels faster than the speed of light.
Yeah, we could really do with a recognized physicist working with us on. I think what we probably need to do is we need to have two papers, I think. One which talks about the nature of systems, yeah, which would include, this relationship, this our holon, Popper's worlds, the essential physics, in terms of, what we're talking about, there's the nature of systems, yeah, but then there's another paper, I think, which is about our engagement with systems, yeah, and that engagement with systems is actually an instantiation of the general system model, yeah. And I think on that first paper we probably need the help of a physicist.
Yeah, it'll have to be a physicist who is who thinks along similar lines.
Yes. Yeah.
I can imagine there are physicists who would disagree with it.
Well, Carlo Rovelli might be a good one. So I could get in contact with Carlo via some people I know who know him. So he might be interested.
Yeah, we'll have to read his book.
Yeah, yeah.
What's the title of his book?
It's called Helgoland.
Say it again.
Helgoland.
How do you spell Helgo?
Helgo land. Yeah. It's where Heisenberg, suffering with hay fever, he went to a battered island in the North Sea called Helgoland. It was there that he came up with the key insight behind quantum mechanics. So that's why it's called Helgoland. It's named after Werner's trip to the island.
Gary, I think we've done enough for this morning.
Yeah.
Because we need to think.
Yeah. Yeah.
I will try to draw out 7 or 10 points or so to try and sum up our discussion today. It'd be helpful to have your recording. I'm glad you suggested recording it because we need to capture the ideas and express them succinctly in a language that people like Patrick, for example, could understand.
Yes.
And I think why the reviewers had difficulty with your paper is that they didn't get any, and I certainly didn't on first reading, get any of this at all.
Yeah, yeah. No,
because I think you've expressed it so densely that if now I read it knowing after our discussion, I can see what you're saying, but before I couldn't.
Yeah.
So we've got to say it more simply.
Yeah. David, that gives me real
We've got
joy.
to unpack it, as it were.
Yeah, yeah. It gives
Okay.
it gives me real joy that you can now see that. Because one of the things that I find really frustrating is when I put across these ideas that people can't understand them. And you've taken the time to listen to me and read it and really think about it. And you I just can't express how important and how meaningful that is for me that you've taken the time to do that. It's really appreciated. So I want to thank you for that.
Well, no, I mean, this is what I enjoy doing, exploring new ideas and bringing them to bear on the problems that because in the end, I think the philosophers and physicists and so on take the intellectual high ground, and in many ways, rightly so. But I don't think, because we don't connect very well from their understanding to doing the job, as it were, in practice with engineering, because we've not got that connection. We have connections, the simple ones, but we haven't got deep connections. But the shallow connections is, we use Newtonian mechanics to express the dynamics of a system, in a differential equation, which is what we teach students. But we haven't got the philosophical connection, which what this is doing. And I think in the status of engineers and the quality of their thinking sometimes suffers from the fact that they don't reflect deeply enough about what it is that they're doing and modeling, and because we don't have a philosophy underpinning the approach. And I think that's why engineers are not really appreciated in society, certainly by intellectuals. I mean, in practice they are, because we make things that people want.
Yes.
And people are very impressed, I mean, when you look at your mobile phone and all the stuff it can do, it is very, very impressive.
Yes.
But there isn't that depth of understanding. Anyway, I think you're right about 2 papers as well. So let's take it slowly and get an agreement on what we're actually trying to say. And from that, we can then build a paper. So the first thing I will do is try to write a number of statements, and then you send them to you. You can alter them and modify them and change them. But if you could send me the recording,
I will do.
I can use that as a basis for producing the list. If I will also get Carlo Rovelli's book and have a read of that, and then explore on the internet this idea of potential and relativity of movement, so we can build up from that basis. I mean, we don't have to go deeply into relativity, other than to recognize that the frame of reference of what you're saying is important. The observer moving and relative to the sort of signal that you get when the train passes by and it changes in pitch.
Yes.
That kind of understanding of where you're coming from. I mean, that's the context, isn't it? And as long as you're clear about the context, that's fine. You can model what you like, but often we're not clear about context. We don't state the context. And that's when we get into trouble, because we use things out of context and they don't work.
Yeah. Yeah.
And, you know, at a higher level, we see that all the time in engineering failures. People using stuff out of context. Anyway, okay, let's leave it at that. And
Thanks a lot,
I've
David.
got to go and get my wife.